Every day, millions of workers in the United States go to their workplace and use chemicals as a part of their daily routine. Many of the chemicals we use can be dangerous if they are not stored properly or if we are not using the right equipment to protect ourselves while using the chemical. For over 30 years in the United States, employers who work with chemicals were required by the Occupational Safety and Health Administration, or OSHA, to follow regulations relating to the safe handling and storage of chemicals in the workplace. Those regulations were called the Hazard Communication Standard. In 2012, the Hazard Communication Standard was revised to incorporate GHS-based labeling and information requirements. So what is GHS, and how does it affect you and your workplace? Let's take a look. What is GHS? GHS stands for the Globally Harmonized System of Classification and Labeling of Chemicals. GHS was conceived and adopted by the United Nations in 1992. The intent of GHS is to standardize the way information on chemicals is determined and then how that information is transmitted to distributors and users of a chemical while in transit or when stored or used. The goal is the safe transport, storage, use, and disposal of chemicals worldwide. Why was this necessary? Many of the chemicals we use or are exposed to are produced or imported from foreign countries. There was no standardization on how a chemical was determined to be hazardous, or even how hazardous a chemical is between different countries. For example, a chemical could be classified as hazardous by one country, requiring special procedures and equipment, while another may consider the same chemical as non-hazardous with lesser or even no requirements for safe handling of the chemical. In addition, the labeling of a chemical can differ from country to country, or even between different manufacturers in the same country. The confusion caused by these differences may have played a part in many of the chemical accidents that have occurred worldwide because of the misunderstanding of the handling or storage requirements for the chemicals. Even though GHS was formally adopted by the United Nations, it is considered a non-mandatory or non-binding agreement. It is not a regulation or a standard under United Nations laws. This means that even though a country may be a member of the UN, that country is not required to follow or adopt GHS. Some countries are already working under GHS, while others are preparing to adopt or implement the system. Still others have not decided whether to adopt the system, and some have rejected the system entirely. Even in the United States, there was confusion about the requirements for labeling and information about a chemical, depending on which governmental agency had jurisdiction. The Consumer Product Safety Commission, the Environmental Protection Agency, the Department of Transportation, and even OSHA had different requirements for labeling and information. The adoption of GHS by the United States will not only reduce confusion among users and transporters of the chemicals, but will also reduce regulatory issues with these agencies by standardizing the requirements. The OSHA Hazard Communication Standard, or HCS, is a part of the General Industry Standards. It can be found under 29 CFR 1910.1200. The original Hazard Communication Standard was published in 1983. This was commonly known as the Right to Know law because every employee has the right to know what is in the chemicals they use and what equipment and procedures are needed to protect them from injuries and illnesses that could be caused by the chemical. The standard required employers to provide training on chemicals used in the workplace and to have the MSDS and required personal protective equipment available for employees to use. The United States Department of Labor officially adopted the GHS system on March 26, 2012. The Hazard Communication Standard has been revised to reflect these changes. The revised Hazard Communication Standard is now known as the Right to Understand Law, or HAZCOM 2012, and is still found in 29 CFR 1910.1200. Although the Hazard Communication Standard is not detailed in the 1926 construction standards, it is incorporated by reference from the General Industry Standards. This can be found under 29 CFR 1926.59. Who is affected by these changes? Over 5 million workplaces and 43 million employees will see changes in the information and labeling of the chemicals used in their workplaces. The majority of procedural and process changes will not affect workers, but instead put requirements on manufacturers and distributors of the chemicals. This includes changes to the classification and labeling of the chemicals, as well as changes to the information transmitted to employees who will use the chemicals. The criteria for determining the hazards of a chemical will become standardized for countries who participate in GHS. Hazard classes with subcategories for each class have been established. The labels for chemicals are being standardized to eliminate multiple labeling systems. Currently, labels must conform to different requirements depending on which regulatory agency has jurisdiction over that particular area. For example, chemicals being transported must bear labels and placards conforming to U.S. DOT requirements, while others must be labeled under requirements from the National Fire Protection Association or other regulatory agencies. This creates an environment where employees must be able to understand the different labeling systems. Another change that will directly affect employees is the redesign of the Material Safety Data Sheet, or MSDS, currently in use. The new format, called the Safety Data Sheet, or SDS, is required to be published in a standardized format instead of the multiple designs currently used. Although GHS has been formally adopted in the United States, there will be a 3-year phase-in period during which manufacturers, distributors, employers, and end users will switch over to the new GHS format and conform with its requirements. There are 4 target dates established for compliance with the GHS system. The first target date, and the one that affects the majority of the employers and employees in the United States, requires employers to train their employees on the GHS system before December 1st, 2013. This training will teach employees how to read and understand the new labeling system as well as the safety data sheets. By June 15, 2015, all manufacturers and distributors of chemicals must complete the hazard reclassification of the chemicals they produce and create GHS compliant labels and safety data sheets. Even though all new labels must meet the guidelines of the GHS system, distributors are allowed an extra 6 months to use up existing stocks of already labeled containers and stocks of old style labels. After that 6-month period, distributors must comply with all the GHS requirements. This includes GHS compliant labels and safety data sheets for all chemicals produced or exported by manufacturers and distributors. Finally, on June 1st, 2016, all employers must be in full compliance with the revised Hazard Communication Standard. This includes any revisions to company hazard communication programs so that all GHS-related changes are adopted into the programs. The Department of Labor estimates that the adoption of the GHS system will save employers over $500 million annually. Additionally, OSHA predicts that it will be instrumental in preventing 43 worker fatalities and 585 worker injuries each year. The GHS system classifies chemicals as to the type of hazard or hazards they may involve. The 3 major classifications are physical, health, and environmental hazards. These classifications are denoted by a diamond pictogram with a red border. The red border is a GHS requirement so that it will draw attention to the label and warn employees that the chemical contains one or more hazards. This is required for all container labels. Some chemicals may have more than one hazard. When this is the case, pictograms of the classification for each hazard must be on the label. For example, this chemical presents two different types of hazards. It is highly flammable, which is a physical hazard, but it also poses a health hazard if it is swallowed or inhaled. Under GHS guidelines, the pictogram warning of the physical hazard as well as the pictogram for the health hazard must both be present on the label. Physical hazards are those that can cause explosions or fires or react when exposed to air or water. These include explosives, flammable gases and aerosols, oxidizing gases, gases under pressure, flammable liquids and solids, self-reactive substances, and pyrophoric liquids and solids. Pyrophoric chemicals are those that react with air to cause a spontaneous fire. Other physical hazards include self-heating substances, substances which emit flammable gases on contact with water, oxidizing liquids and solids, organic peroxides, and substances corrosive to metals, such as strong caustics or acids. A health hazard is one which can cause illness, injury, or death by entering the body. These hazards include acute toxicity, skin corrosion or irritation, serious or other eye damage, or a respiratory or skin sensitizer. A sensitizer is something that causes the respiratory system to become hypersensitized if inhaled, or an allergic reaction on the skin if contacted. Others include germ cell mutagenicity, carcinogenicity, reproductive toxicity, specific target organ toxicity, which means a chemical attacks a certain organ or organ system in the body, and asphyxiation. The environmental hazards pictogram, along with its inclusion in safety data sheets, is not mandatory at this time since OSHA does not have jurisdiction over environmental issues. The two categories of environmental hazards are acute and chronic aquatic toxicity. Acute means the chemical causes immediate harmful results to aquatic life, and chronic means that the chemical requires time to build up to a toxic level. There are 9 different pictograms that will be used to identify hazardous chemicals under the Hazard Communication Standard. A pictogram may be used to represent one or several hazards. Under each of the 9 pictograms, a subcategory defining the actual hazard is listed. Each of those subcategories may be further broken down using threshold limit values or other GHS-based limits to standardize classification of the chemical. All chemicals under the Hazard Communication Standard will bear standardized labels. Although these labels may vary somewhat in their format, every label must have information that is required by the standard. This information includes the product identifier, usually the trade name or common name of the chemical. The product identifier on the label must match the product identifier on the safety data sheet. A signal word. The only allowable signal words are danger for severe hazards and warning for less severe hazards. The manufacturer will classify the chemical using GHS-based guidelines to determine which signal word is applicable. Hazard statements. These give a brief description of the potential hazards of the chemical. These are taken from a list of GHS-based standard statements based on the classification of the manufacturer. Precautionary statements. This section gives information on methods and personal protective equipment necessary to handle the chemical, storage and disposal requirements, and first aid measures. The supplier identification for the chemical, including the name, address, and telephone number of the manufacturer or supplier. And the pictograms, giving a visual clue as to the nature of the hazards of the chemical at a glance. Although the layout of the labels may differ from company to company, the required information must be on the label. The information on the labels provides a quick overview of the hazards that are associated with the chemical. More detailed information is found in the Safety Data Sheet, or SDS. The information on the label must match the information on the SDS. If you notice a chemical container that has a damaged or missing label, notify your supervisor so that they may obtain a replacement label and place it on the container prior to being used. The old Hazard Communication Standard required that all employees be trained about the use and potential hazards of any chemical in the workplace. This was normally done using the Material Safety Data Sheet, or MSDS, for that chemical. The standard also required that a copy of the MSDS for each chemical in the workplace be available to employees so they could refer to it if necessary. Under the new Hazard Communication Standard, employers are still required to provide the training on all chemicals, but the format of the information sheet has changed. The new format drops the material from the title and calls them Safety Data Sheets, or SDS. The SDS can be in a printed format as under the old standard, but now can also be accessed electronically. It is recommended that if electronic access is used, a way to print out the SDS should be available in case a portable copy is needed. The information provided in the Safety Data Sheet is divided into 16 headings. 3 of the 16 headings concern environmental and transport issues. These are considered non-mandatory by OSHA because they do not have jurisdiction over these areas. Section 1. Identification of the substance or mixture and of the supplier. This section lists the GHS product identifier, which should match labels for the chemical, any other means of identification of the chemical, the recommended use and any restrictions on use of the chemical, the supplier's contact information, including name, address, and phone number, and an emergency phone number for information during a chemical emergency. Section 2. Hazards Identification. This section lists the GHS classification of the substance or mixture, any national or regional information, GHS label elements including precautionary statements, and other hazards which either have no classification or are not covered by GHS. Section 3. Composition and information on ingredients. This section is used to identify the chemical or components of a chemical mixture. This is listed by the chemical identity, the common name and any other names used, such as trade names, the chemical abstract surface, or CAS, number and other common ID numbers, and anything else contained in the chemical, such as stabilizers or impurities. If the SDS is for a mixture, then the identity and concentration for all hazardous chemicals in the mixture must be identified. Section 4. First aid measures. This section describes necessary first aid measures broken down by the different routes of exposure, the most important symptoms or effects of exposure, and any immediate or special medical treatment that may be required. Section 5. Firefighting measures. This section lists the type of extinguishers that should and should not be used on the chemical, any specific hazards that the chemical produces while burning, and special protective equipment and precautions for personnel involved in fighting the fire. Section 6. Accidental release measures. This section describes precautions, PPE, and procedures to follow in case of a spill, any precautions that should be taken to protect the local environment, and methods and materials suitable for containing and cleaning up the chemical. Section 7. Handling and storage. This section provides precautions for safe handling of the chemical as well as conditions required for safe storage. This may include information on chemicals which are not compatible with each other. Section 8. exposure controls, and personal protection. This section provides information on exposure limits, appropriate engineering controls, and the necessary PPE to wear while handling or using the chemical. Section 9. Physical and chemical properties. This section gives a detailed description of the chemical and its characteristics, such as appearance, odor, odor threshold, pH, melting or freezing point, boiling points and range, flash point, evaporation rate, its flammability, the upper and lower explosives or flammable limits, vapor pressure and density, relative density, solubilities, and autoignition and decomposition temperatures. Section 10. Stability and reactivity. This section describes the chemical stability, any possibility of hazardous reactions, any conditions to avoid, any incompatible materials, and any hazardous decomposition products. Section 11. Toxicological information. This section lists information relating to the health effects of exposures to the chemical, such as the most likely way it will enter the body, symptoms of exposure, delayed and immediate effects of exposure, and measures of toxicity. Sections 12 and 13 are the environmental sections. These are not required by OSHA, but may be required by another regulatory agency. These sections deal with the effects of the chemical on aquatic and other environments, including the adverse effects of the chemical and how to properly dispose of the chemical. Section 14. Transport information. This section details the UN number and proper shipping name, the transport hazard classes or packing group if it is a marine pollutant, and any special precautions to be taken while in transport. Again, because OSHA has no jurisdiction in this area, this section is also considered non-mandatory. Section 15. Regulatory information. This section lists the applicable safety, health, and environmental regulations that apply to the chemical. Section 16. Other information. This section will include miscellaneous information, which may include the preparer's name and title, the date of preparation or revision, and other related information. The complete transition between the old Hazard Communication Standard and the new GHS-based Hazard Communication Standard will take 3 years to implement. In that time period, you will start to see more and more GHS compliant labels and fewer old-style labels. You should already have received training on the chemicals you already use. Your employer will train you on the chemicals that are introduced into your workplace. Pay attention to the labels when working with or around chemicals. Check the label to see if there are any red border pictograms. This will let you know immediately that the chemical is hazardous. Read the label to see what hazards are present and what precautions you need to take. If you need more specific information, obtain and review the safety data sheet for the chemical. Obtain the correct PPE for the chemical and its hazards to protect yourself. All that's left is to perform the work safely so you can return home to family and friends.